Hello students, welcome. Previously, lesson 1, form 3 topic 4, we were dealing with the introduction of the chemistry of nitrogenous compounds and we have seen laboratory preparations of nitrogen gas. So today lesson 2, we want to proceed to industrial preparation of nitrogen gas, or is also known as large scale manufacture of nitrogen gas. Remember learners, large scale production or large scale manufacture of nitrogen and oxygen was taught in chemistry form 1 under chapter 4, that's air and combustion. So we are going to do the same thing as we have done in chemistry form 1. We are saying nitrogen is prepared on large scale through fractional distillation of liquefied air, and we are having this summary on the fractional distillation of liquid air. First of all, we are supposed to have our air here, and it will be passed through filters or air filters, and the reason is to remove dust, and the dust-free air is passed through concentrated potassium hydroxide solution or sodium hydroxide solution, and that's in order to remove carbon dioxide from the air. So that means air free from dust particle and also carbon dioxide is passed through the cooler chamber, or which is also known as the condensation chamber. And there we're having conditions, and the condition there is we're having a temperature of negative 25 degrees Celsius, and the reason of passing the air through the condensation chamber is to remove the water vapor. Here we're having air free from water vapor, and the remaining part of air now will go through the compressor. So in the compressor we're having two conditions of temperature and pressure. Temperature of negative 200 degrees Celsius and pressure of 200 atm atmospheres. So there we are going to get liquid air, and that liquid air will go through the fractional distillation chamber, where we are going to check their boiling point. The boiling point of oxygen is negative 183 degrees Celsius. The boiling point of argon or noble gases is negative 186 degrees Celsius, and the boiling point of nitrogen is negative 196 degrees Celsius. So nitrogen is the one that's having the lowest boiling point, so it will be distilled off first as the first fraction. So we want to proceed to see the parts of the fractional distillation process. So we're having parts of the fractional distillation process. The first part, that's the filter chamber or filtration chamber. So we're saying here air is first purified. How is it purified? By passing it through filters. What is the role of those filters? We are saying the role of the filters is to remove dust particles from air through electrostatic precipitation. So what's electrostatic precipitation? Is the process of removing dust particles from the air, or by the use of filters or air filters. So I told you a note, electrostatic precipitation involves passing air through chambers containing jagged plates that attract the dust particles. To see the first part, the part that we are talking about is here. Air is first purified by passing it through filters, and the role of these filters is to remove dust particles. So we're done with the first part, or the first chamber of fractional distillation process. So we're going to go to the second chamber, and it is here, the second chamber. So the second chamber is called absorption chamber. Absorption chamber. So I told it contains concentrated sodium hydroxide or potassium hydroxide, and the role of sodium hydroxide or potassium hydroxide is to remove carbon dioxide from the air. If we see that chamber, it's having potassium or sodium hydroxide solution. That's why we're saying the absorption chamber contains concentrated potassium hydroxide solution or sodium hydroxide solution. And the role of this potassium hydroxide solution or sodium hydroxide solution is to remove carbon dioxide from the air. That's why we are having here carbon dioxide free air. So we are going to go to the third chamber, or the third part of fractional distillation process. That's the condensation chamber, which is also known as the cooler chamber. So we are going to go to the third chamber. It's called the cooler chamber or the condensation chamber. Condensation chamber. Condensation chamber. We are saying water vapor is removed by cooling the air to negative 25 degrees Celsius as ice. So what we mean here is that we are removing water vapor as ice or solid ice. So a tool note, temperature in the cooler chamber is negative 25 degrees Celsius. hence is below the melting point of water, which is 0 degrees Celsius. So we're having negative 25, so that means we are going to remove water vapor as ice. So we are going to proceed next to the fourth chamber, that's called the compressor chamber. We are told the remaining part of air is compressed to a pressure of 200 atmospheres and allowed to expand. Repeated compression and expansion of the gas cools it to liquid at negative 200 degrees Celsius. So let's now see the role of the compressor. We are told it's used to liquefy the air. So the condition used in the compressor chamber is 2, and even we have seen here, we have seen pressure of 200 atmospheres and also temperature of negative 200 degrees Celsius. So we're talking about temperature of negative 200 degrees Celsius and pressure of 200 atmospheres. That is the fourth part or the fourth chamber in fractional distillation process. So we're going to go to the last one. That's the fractional distillation chamber. We are saying the liquid air consists of nitrogen, oxygen, and noble gases. Because when we are talking about components of air, they were including dust particles. Number 2, we were having carbon dioxide. Number 3, we were having water vapor. Number 4, we are having maybe oxygen. Number 5, we're having nitrogen. Number 6, we're having noble gases or argon there. So dust particle has been removed in the filter chamber. Carbon dioxide has been removed in the absorption chamber by sodium hydroxide solution or potassium hydroxide solution. Then water vapor is removed in the condensation chamber or the cooler chamber because it has been removed as ice. Then we are remaining these 3: oxygen, nitrogen, and also noble gases or argon. That's why we're saying here the liquid air consists of nitrogen, oxygen, and noble gases. Since these gases have close but different boiling points, they can be separated by fractional distillation. The next we are saying nitrogen gas with a low boiling point of negative 106 degrees Celsius distills out first as the first fraction, followed by argon at negative 186 degrees Celsius, and finally oxygen with a higher boiling point of negative 183 degrees Celsius compared to argon and nitrogen. Note, we are told water and carbon dioxide are removed before compression. The reason why we are removing them before compression is that because we are told they solidify at low temperatures. The temperature that we were having in the compressor chamber was negative 200 degrees Celsius. So they will be solidifying it. Hence, cause blockage of the pipes, which will interfere with flow of the liquid air. That's the reason why water and carbon dioxide are removed before compression. So next we are going to go and see physical properties of nitrogen gas. The physical properties of nitrogen gas include it's a colorless and odorless gas. That means it has no odor, it has no smell, in other words. Number 2, we are saying it's slightly soluble in water. Nitrogen is slightly soluble in water. Number 3, it's slightly less denser than air. Then number 4, we are saying it's slightly soluble in water. Those are the physical properties of nitrogen gas. Learners, that's the end of our class today. Thank you for watching.